Good morning. Welcome to section 1.2. We're going to talk about simplifying rational expressions today. Before we get started with simplifying them, we should probably talk about what they are. So some examples of rational expressions, the word rational means fraction. So an example of a rational expression would be 1/2, or a squared minus b squared over a plus b. This second part is really what we're going to look at today and being able to simplify those. So a few things that we want to talk about before we start simplifying them is you got to be able to factor. Everything with rational expressions goes back to the ability to be able to factor. So that's the first thing we're going to look for, is to be able to factor anything we can. If you're multiplying or simplifying a rational expression, then we can cancel common factors in the numerator and denominator. So if we have a common expression in numerator and denominator, we can cancel those out. When we divide, we're going to flip the fraction after the division sign, and then we're going to change that problem to multiplication, and then we simplify it just like a multiplication problem. And when you add and subtract rational expressions, remember you have to have a common denominator. So let's go ahead and jump into a couple of examples here. The first one, here I have 12x squared plus 12x plus 3 divided by 4x squared minus 1. So the first thing I want to do is to factor both the numerator and denominator. First step of factoring, we look for the GCF. So if I look at my numerator, 12x squared, 12x, and 3, I can pull a 3 out of that. So I take my 3 out and I end up with 4x squared plus 4x plus 1. And that's going to be divided by, I don't have a common factor for the denominator, so I'm going to leave it as 4x squared minus 1. A lot of people like to go ahead and say, hey, I have 4x squared in common. That's a big no-no, because this 4x squared in a numerator is part of a trinomial. Remember, trinomial means 3. And the bottom denominator there is a binomial. And you can't cancel pieces of monomials, binomials, and trinomials. They have to be exactly the same. So in order for these to cancel, I would need a 4x plus 1 down here instead of this minus 1. But what I can do is go ahead and factor this into two binomials. So remember, when factoring, this first term is coming from when we multiply the first two terms of my parentheses. And I can either do a 4x and a 1x, or I can do a 2x and a 2x. And some of you are just going to do a trial and error and hopefully get the right answer on the first try. So I'm going to try 2x and 2x. This 1, that's a prime number, so I know it's got to be a plus 1 and a plus 1 in order to get us to multiply to get us that 1. But remember, that middle term has to come when we multiply the outside numbers and then the inside numbers and add together. So if I take my 2x times my 1 gives me a 2x, and my 1 and my 2x gives me 2x. So if I add those together, that's got to give me that middle term of 4x, which this does. 2x plus 2x gives me my 4x. So if I were to multiply this out, I would get 4x squared plus 4x plus 1. My bottom, 4x squared minus 1, hopefully we see that as the difference of perfect squares. So we get 2x minus 1 and a 2x plus 1. Now that I'm factored completely, I can go ahead and cancel any terms that are the same. So notice now I have the common factors of 2x plus 1 in common. So this is going to simplify to 3 times 2x plus 1 over 2x minus 1. We could leave that denominator in parentheses if we want, or we can take it out since there's nothing being multiplied to it. Again, we cannot cancel either of these parts, the 2x or the 1, because they're different binomials. They have to be exactly the same. Here we have a multiplication problem. Ooh, and look, we have multiple variables, your favorite, I'm sure. So I'm going to go ahead and look at a squared minus 6ab plus 9b squared. I don't have a GCF. So I'm going to go into factorization of it. My first term is going to be a and a. To get my 9b squared, it's looking to me like it's a 3b and a 3b. In order to get that 6, in order to get a negative 6, when I add these together, both of my terms have to be negative. So now when I multiply these together, I get a positive 9b squared. When I multiply these two together and these two together, I get 2 negative 3ab's. 2 negative 3ab's added together gives me negative 6ab. Again, if I multiply this out, distribute it out, I'll end up with that term or that expression in the end. Here I'm going to go ahead and factor my a squared. Again, I have a and a. I'm going to break up my negative 6b squared, so I get a negative 1. Remember, there's a 1 in front of there. So I'm going to break it up as negative 3b and a plus 2b. That's going to give me my negative 6b squared when I multiply them together. And when I multiply my insides and my outsides and add those together, I'm going to get my negative 1. So again, negative 3ab, positive 2ab, negative 3ab plus 2ab gives me a negative 1ab. Here I have a GCF of 3. So I can pull that out. I get 3 times a plus b. And here, this one's going to be a little different. It's going to take us a little bit of thinking. So I have my 2a and my a. I'm going to break up my 3b squared. So the only way I can break up 3b squared is 3b and b. But I gotta get this negative 7 out of it. So if I multiply 2 to 3, that gives me 6, and here's a 1. 6 and 1 gives me a 7. So I'm gonna put my 3b here and my b here. Again, we need a negative when we add them, positive when we multiply these terms. So I know it's gonna be a negative and a negative. Again, we can multiply this out, distribute your 2a to both of them, your negative b to both of them. And that should simplify to our original expression. Now comes the fun part. What can we cancel? Well, we have an a minus 3b and an a minus 3b here. So we can cancel out one on the top and the bottom. We can also cancel across the multiplication symbol. So we can cancel this ab, or a plus 2b there. I can cancel that one with this one. And then this a minus 3b, I have one down here in the denominator as well, so I can cancel that one with that one. So I have left 3 over 2a minus b. And that's going to be our final answer. I'm going to go ahead and do a division problem here real quick. So remember division, we're going to change the multiplication by flipping or reciprocating that second term. And if you want it, you could go ahead and factor along the way. It's up to you. I'm going to go ahead and flip the start. This one, we don't really need to factor anything. It's 2y minus x squared. So that just means that we have 2 of them. If you feel like writing that out twice, you can. Probably going to be something that we're going to look at. So if I come up here, I can go ahead and factor that first term. So I have 3x and I have x. I got to break up my 4. I can either do 1 and 4, 4 and 1, or 2 and 2. I'm going to go ahead and with 2y and 2y. I need a negative 4 when I add them. So if I take my 6xy here, my 2xy here, I know I've got to get a negative 6 and a positive 2 in order to add to give us that negative 4. Again, that's over xy squared times x to the third y over 2y minus x squared. Now if I look for things that are common, well, here I have a monomial in the bottom and I have a monomial on top, so I can cancel pieces of monomials since there's nothing being added together. X squared y simply means x times y. And over here we have x times x times x times y. So they're all being multiplied together. So I can cancel anything that's in common. So I can cancel one of these x's, I can cancel another x, can't cancel the last x because there's not another x down here, but I can cancel this y out. So that leaves me with just that x on the top. Now if I look at my binomials, notice this 2y minus x, very similar to this x minus 2y. What I can do is rearrange this, so I get negative x plus 2y squared, looking a little more like it. If I factor out a negative out of this, I can take a negative of x minus 2y squared, again looking very close to it. in order to take this negative out, remember that's a -1. We're going to square each of these in here. So I'm going to take and break this into -1 squared times x minus 2y squared. -1 squared is 1, and 1 times anything is itself. So essentially, we have x minus 2y quantity squared in our denominator. Now we can cancel one of those. So we're going to cancel that one. That squared is going to go to a 1. So we'll end up with x times 3x plus 2y over x minus 2y. And that's an example of a division problem. We're going to go ahead and do an addition problem here. In order to add, we want to have common denominators. Again, we want to go ahead and factor that denominator. Notice my 1 minus x and my x minus 1, again, we don't like that form. So we can pull a negative out of it. If I pull a negative out, that's essentially going to flip those two around. Here, x squared minus 1, difference of squares. So we get x minus 1, x plus 1. This negative, remember, it can float. It can go to the outside or it can go to the top. And when I add and subtract, I want to go ahead and pull that up just to get rid of it. It makes my life a little easier. So I can write it as -x over x minus 1 plus 2x plus 3 divided by the quantities of x minus 1 and x plus 1. Now I can go ahead and find a common denominator. Notice I have x minus 1's in common. So my x minus 1 is part of my denominator. And I'm also going to pull what I don't have in common, which is going to be this x plus 1. And that's going to be my common denominator. Now I'm going to look, what does this denominator need to make it look like my new denominator? And that's essentially going to get multiplied to my numerator. And that's going to be an x plus 1. Over here, I have x minus 1 and x plus 1. That's what I want in my denominator. So I'm going to leave this numerator alone, since I don't need to multiply it by anything to make it look like that denominator. Now I can go ahead and simplify my numerator. Multiply my -x through, I get -x squared minus x plus 2x plus 3. And again, that's over my common denominator, x minus 1, x plus 1. I can go ahead and simplify inside there, so I get a -x squared plus x plus 3 over x minus 1, x plus 1. At this point, I want to look at my numerator and see if I can factor that. The only thing I really could do would be take out a -1. If I took out a -1, I get x squared minus x minus 3 over x minus 1, x plus 1. This trinomial is not going to factor for me, so it really doesn't matter if I pull that negative out or not. So either one of these would be equivalent answers and acceptable answers for a quiz or a test. The last thing I want to do is do a complex rational expression. So a complex rational expression just means that we're doing things to the numerator and denominator, and we've got addition, subtraction, multiplication, division kind of happening all in the same problem. So what I like to do is to work with the numerator first, denominator second, and kind of work them separately to simplify as much as I can to get a common denominator. So here I have a common denominator of xy. So this term is going to need a y in order to get it to be xy, so we're going to multiply the top by a y as well. And that gives me y squared. This y needs to be multiplied by an x in order to get to xy, so I'm going to multiply the numerator of x by x, and I get x squared. I'm going to do the same thing in the bottom. My common denominator is xy. So I'm going to multiply the first term by y in order to get a common denominator, and that's going to be plus x. Now I have a fraction divided by a fraction, and that goes back to a division problem. So I could write this as y squared minus x squared over xy divided by y plus x over xy. And within that division problem, now I can change it to multiplication. I'm going to go ahead and factor as well, since I see that I'm going to have to factor it. and that's over our xy. Change our division to multiplication, and we're going to flip or reciprocate that second term. Now I can go ahead and cancel any of my like terms. So my like terms are xy in the numerators and my y plus x in my numerator and denominator. So now I can go ahead and simplify this to a y minus x. And that's going to end our simplifying rational expressions for day one. Good luck.